Math Models Thanksgiving Break Packet 2010. That's Mr. Sebastian on the left who put this together for us. During this video I'm planning to work out most of the odd numbered problems so you can carry on and do the rest of them the same way. These problems are systems of equations problems, and the first 6 on the first side call for solving by graphing. For this system, problem 1, start the first equation at the y-intercept of 4. With the slope of -3, that's -3 over 1, so it's down 3, here marked in green, and over 1 to the right. We draw our second point. Then draw the line through the 2 points. That looks fairly accurate. For the second line, we take the y-intercept of -2, and from here we have a slope of 3, or rise over run of 3 over 1, so we go up 3, shown with the blue line segment, and then over to the right 1. Then we make a point here. Do you notice that it's right on top of the point of our other line? Then we draw a line through the points. Our solution by graphing is 1, 1. Finally, we test the coordinates of our solution by plugging the coordinates into the original equation. The first equation works because when x is 1, y is 1, check. And for the second equation, we have 3 times 1 minus 2 equals 1, check. We know we didn't make a mistake because both equations checked out. For this system of equations, we'll solve by graphing as well. Problem 3. We'll prepare to graph by solving each equation for y, and we'll start with this one, x minus y equals 3. There are different ways we can do this, but we'll just leave y where it is and subtract x from both sides of the equation. X minus x cancel on the left side. We bring down what we have left, negative y equals 3 minus x. Next we solve for y by dividing everything by -1. That just changes the sign, so we have y equals -3 plus x. To graph this, we start at the y-intercept of -3, and since we have 1x, that's a rise over run of 1 over 1. So we mark that off on our y-intercept and then draw our second dot. We go to the right, we draw the line. And now the second equation, 7x minus y equals -3. Our first step is to subtract 7x from both sides of the equation. 7x minus 7x cancel on the left side. We bring down what's left, negative y equals -3 minus 7x. We solve for y or make it positive by dividing all the terms by -1, so we have y equals 3 plus 7x. We start at our y-intercept of 3. Then we have the rise over run of 7. Since we don't have enough room to rise 7 from the y-intercept of 3 on the graphing area, we have to work backwards, so we draw the run to the left side of 1 unit. Then we draw the rise of 7 downward since we're working backwards. Then we mark our second point. Then we draw our line as we have done. Our solution is -1, -4. We plug in the numbers for x and y and check our solution. X minus y is -1 minus -4, and since that equals 3, that equation checks out, check. And we try out the other equation, 7 times -1 minus -4, which equals -7, plus 4, which equals -3, check. Now we're sure we got it right. Here's problem number 5. We'll first solve for y to be able to graph. For this first equation, 8x plus y equals -4. We subtract 8x from both sides of the equation. 8x minus 8x cancel on the left side. We bring down what's left, y equals -4 minus 8x. We mark our y-intercept at -4. Next we draw our rise over run of -8 over 1. Since we don't have room to draw down 8 from the y-intercept, we'll have to work backwards. We move our run first, and since it's backwards, we go to the left 1 unit. And since we're working backwards, we go up 8 from here. Then we draw in our second point. Then we draw our line through the points. Next we'll go to work on our second equation and solve for y. We have 0 equals -4 minus y minus 8x. The easiest thing to do to solve for y is to bring the minus y over to the left side of the equation so it becomes positive. So we bring down what's left and we have y equals -4 minus 8x. And we can go ahead and graph, but I noticed something here. The equation is the same as the first equation we graphed. And since both equations are the same, we can say that all points are in common, and our answer is that there is an infinite number of solutions. If you have questions about the even-numbered ones, just ask me a question if you have one. Now we're down to our solving by substitution section. And in this one, problem 7, since both equations are both solved for y, we can set the x expressions equal to each other. So we have 4x minus 9 equals x minus 3. I like to solve with the unknowns on the left and the numbers on the right, so we'll start by subtracting x from both sides of the equation. X minus x cancel on the right side. We bring down what's left, so we have 3x minus 9 equals negative 3. Next, we add 9 to both sides to cancel the minus 9 on the left side. Negative 9 plus 9 cancel on the left side. We bring down what's left, and we have 3x equals 6. And solving for x, we have x equals 2. And then we can substitute 2 for x into one of our original equations to find the value of y. So we have y equals 2 minus 3. So y equals negative 1. So our solution is 2 comma negative 1. And to be sure, we try the coordinates in the first equation as well. And since 4 times 2 minus 9 is negative 1, that checks out as well. So we're sure we have the right answer. Now for this problem, problem 9, we have y equals negative 5 and 5x plus 4y equals negative 20. We already have y solved for. We just replace y in the second equation with negative 5. So we have 5x plus 4 times negative 5 equals negative 20. This simplifies to 5x minus 20 equals negative 20. We add 20 to each side of the equation. Negative 20 plus negative 20 cancel on both sides of the equation. We bring down 5x equals 0. Dividing both sides by 5, x equals 0. So our solution to the system is 0 comma negative 5. That last problem was quite easy, I think. Now problem 11 is 6x plus 8y equals negative 22 and y equals negative 5. For this problem, we have a value negative 5 to substitute for y again. So we have 6x plus 8 times negative y equals negative 22. You should be able to take it from here and finish solving for x and solve the system. Now for this one, problem 13, 2x plus 2y equals negative 6, and 5x minus 5y equals negative 15. What we'll do with this first equation is to solve for y, and then we'll substitute for y in the second equation. We subtract 2x from both sides of the equation. 2x minus 2x cancel on the left side. Bring down what's left, 2y equals negative 6 minus 2x. Now we divide everything by 2. 2 over 2 cancel on the left side of the equation. We bring down what's left, y equals negative 3 minus x. Then we're going to put this expression for y, negative 3 minus x, in place of y in the second equation. And so we rewrite the second equation as follows. 5x minus 5 times quantity negative 3 minus x equals negative 15. And we bring down 5x plus 15 plus 5x equals negative 15. We can combine the 5x and 5x on the left side. So now we have 10x plus 15 equals negative 15. We subtract 15 from both sides of the equation. 15 minus 15 cancel on the left side. We bring down what's left, 10x equals negative 30. Now divide both sides by 10 to solve for x. 10 over 10 cancel on the left. So we solve for x. X equals negative 3. Now we'll take our x value, negative 3, for x so we can solve for y. So it rewrites here on the right side as 2 times negative 3 plus 2y equals negative 6. That becomes negative 6 plus 2y equals negative 6. Add 6 to both sides of the equation. Negative 6 plus 6 cancel on the left side. We have 2y equals 0. And divide both sides by 2 and y equals 0. So the solution to our system of equations here is negative 3 comma 0. Be sure to check your answers. I checked and they are correct. Numbers 15 through 22 involve solving systems by elimination. For elimination, you eliminate an unknown by adding the equations together or subtracting them. This one's pretty easy. It's already set up to cancel by addition, so we place a line segment below to add. Negative x plus x cancel. We add everything else and bring everything down, and that's negative 4y equals 16. We solve for y by dividing both sides of the equation by negative 4. Negative 4 over 4 cancel to 1 on the left side, so y equals negative 4. We'll place negative 4 into this equation to solve for x. Here's the equation. and below is the equation with negative 4 plugged in. This simplifies to x plus 12 equals 8. We subtract 12 from both sides of the equation. 12 minus 12 cancel on the left side. We bring down our answer, x equals negative 4. So our solution to this system of equations is negative 4 comma negative 4. Now we have this problem, number 17, 4x plus 5y equals negative 9, and 8x minus y equals negative 7. This is not set up to cancel immediately, so let's multiply the bottom equation by 5. And multiplying by 5, we have 40 minus 5y equals negative 35. We'll bring the top equation down beneath the one we changed to be able to add them together better. Adding the equations together, negative 5y and positive 5y cancel each other, so what we have left is 44x equals negative 44. Dividing both sides by 44, we have x equal to negative 1. Now we'll take the negative 1 for x and place it in this equation. So we have 8 times negative 1 minus y equals negative 7. That gives us negative 8 minus y equals negative 7. We'll add 8 to both sides of the equation. Negative 8 plus negative 8 cancel on the left side, so we're left with negative y equals 1. So dividing by negative 1 to solve for y equals 1 divided by negative 1, so y equals negative 1. And our solution to this system is negative 1 comma negative 1. Now we have problem 19, 2x plus 18y equals 22, and negative x minus 9y equals negative 11. Let's multiply the bottom equation by negative 2. That gives us 2x plus 18y equals 22. Do you notice anything? The two equations are now the same. That means that since they're the same line, there is an infinite number of solutions because there is no point that these two lines do not have in common. Here's problem 21. Negative x plus 2/5 x equals negative 3/5 y, and 3y equals negative 18/11 x plus 51 over 11. Owing to time, I'm not going to complete this problem, but I hope to get you started in the right direction. The first thing we'll do with the first equation is rearrange it so that all the terms lie to equations. Now, if you multiply the bottom equation by 5, you'll be able to add the two equations together and cancel the y's, then continue on to solving. And now the last problem, number 23. Write a system of equations with the solution 4 comma negative 3. As a hint, this might be quite easy if you let one of the equations be y equals negative 3. We solved all the odd-numbered problems except 11, 21, and 23, and even on those three I gave you a good head start. I hope this video has helped you. This has been Math Models Thanksgiving Break Packet 2010. Thanks for viewing.